Well, here we are again. We're going to run through one real quick. This was an interesting little thing I helped my buddy Donnie with over there a few years ago, and I had made a presentation about it. So hope you get something out of this. And this was actually a 95 Mustang. It had 100,000 miles on it at the time. You know, this is still a nice car even now. You know, a lot of people like these things. Cranked, but it wouldn't start. The engine cooling fan was always on with the key on. Okay, so here we go. We actually, this one here had been around the world. We didn't know how it came up with this no start problem. Had no history on it really. We just had to figure it out as we went along. In some cases you can go to the service writer and get him to call the customer and give you some information, but in this case we just kind of dove right into it. And the first thing we noticed was they had an aftermarket engine controller hanging on the wire. And when you switched on the key, the engine cooling fan was running all the time. Now, usually what that means, you know, when that happens, it usually means you got a ground issue or the engine controller is unplugged. In this particular case, when the fan's running all the time, you know, I'm typically looking in the direction of something going on with a ground or the PCM or whatever. On some of your Toyotas and stuff, if you unplug the engine coolant temperature sensor, the fan will run all the time. All right, this one here has got a constant control relay module. This is one of the earliest ones where they stacked all these relays together in one of those on those expensive boxes. Now these things didn't fail a whole lot, you know, but some of the newer ones, you know, like for instance, like in the mid 2000s Hyundais. All of the door lock relays on a Sonata is built into the fuse box, like in the 06 and up. I don't know about the 05, but I know for a fact that if you have issues with those little micro relays that are built into the fuse panel inside the car going lousy, you can check them if you know which pins to go to and to power it up and see if they'll pull a load and all. But if $750 for a fuse panel is a drag, and the contacts in those little relays, if the door locks aren't used that much, like to get dirty and all that. But anyway, this particular one here, we had some evidence going on. That's the old new generation star tester, which whenever I had one of those that was operational, that was my tool of choice a lot of the times, because it's really a pretty doggone slick tool. It'll actually do stuff that a lot of other tools won't do. It will generate a signal that you can use to check your speedometer and various other things like that. But one way or another, we hooked it up, we checked the codes, we pulled all the DTCs that are related to automatic transmission hard faults. Okay, so here we are, we're checking the engine controller that's swinging by the wires, and we're getting all these automatic transmission hard faults. Alright, so look at here, we got us a gear shifter sticking out of the console. This is not an automatic transmission. So somebody got an automatic transmission engine controller plugged into this thing just trying to fix it. So here we go. This was going to have the right engine controller. Alright, so we ordered it because the other one wasn't there anymore. Put it in there, it fired up, and it ran pretty well until we did the test drive. And on the test drive it was bucking and snapping and popping, and it just wasn't running right at all. Now, we're sort of getting back to the point of probably why they replaced the engine controller. A lot of the times whenever people are doing DIY work, they'll throw an engine controller at it hoping that that shotgun blast will take care of the whole problem. It can be kind of expensive, unless you're working on an old car that the engine controller doesn't cost very much on, but even rebuilt engine controllers for these vehicles now are pretty pricey. But if you can find a used one, you got to have one with the right number on it. And a lot of times your interchange guy from your salvage yard will help with that a little bit. But anyway, 3,000 RPM above, it was bucking, jumping, backfiring in the exhaust and the intake. Now, thick film ignition and signature PIP are an interesting little thing here. Signature PIP basically means you might see this little vane cup in the distributor that's got all these little windows that they wheel between the magnet and the sensor on that stator in the distributor. Anything you hear that's referred to as a stator is something that doesn't move, it just stays still. Like a stator in an alternator is the part that stays still. The stator in the distributor is the part that doesn't move. other things go past that. So anyway, the long and the short of it was this particular thing, these thick film ignition modules, and you probably remember these modules, like that one right there is a remotely mounted module. The other ones were mounted on the side of the distributor. And that came out in 1984, and it stayed around for a pretty good while. They started mounting it remotely because it runs cooler that way. All right, and so here we go. The open bowl distributor is the one that's got the module mounted on the side of it. It has a stator to plug it in on the inside. Some of the other ones had the same kind of stator, but that basically went out to a module that was mounted remotely. And these typically ran cooler and gave less trouble. When you're replacing one of those, by the way, it's really important that you put the dielectric grease on the back of it so it can carry the heat from the module into the distributor body, which I always thought was kind of silly because that thing gets kind of hot anyway, but that's probably why they moved it remotely and put it on a heat sink. I actually built a little tool out of a module so that I could basically plug it between the harness that plugs in here and in other words, plug it between there and the module itself, and I would be able, if the module was the problem, I would feed the profile ignition pickup signal out to the other module through here. Anyway, I could just plug it in and fire it up and drive it into the shop, which worked pretty good. All right, and so there, just brighten those up so you can get a better look at them. All right, now this is the module here that goes on the heat sink and all. The PCM we'd already replaced. The TFI module was brand new, and it was an aftermarket brand. I found out when I was working at a Ford dealer a long time ago that you could just work your rear end off trying to fix one that's running bad. And I found, to start with, what I would do if I saw an aftermarket thick film ignition module back in those days, what I would do with that thing is I would take that off of there and put a Motorcraft module on it. And about 50% of the time back then, that would fix whatever was wrong with the vehicle. Because their first module would die or something like that, and they'd pop another one on there they got from the parts store for a little bit of money. And I'd start out, if it's at the dealer anyway, they know we're going to put Motorcraft parts on it. And I don't have the time to drive up and down the road and find out that the aftermarket module was a problem to start with, but I don't trust anything that's not Motorcraft. If you don't put a module on there you can trust the brand name of, you're liable to have a comeback, and that costs everybody. Gives you, besmirches your reputation and everything else. Anyway, whoever the horse doctor might have been before, they all had replaced the distributor cap and rotor, but the plug wires were original and they were properly routed. All right. So anyway, I've already talked about that. The TFI module was replaced, but the bucking and jumping never changed. It still had 3,000 RPM at no load, backfiring and snorting. So let's just put a scope on it. And in those days, I had an old CRT scope. I didn't have the fancy, computer scope, the LCD screens and all this kind of fancy stuff we got now. This was the scope I had back then. And when I would get that thing brought up to 3,000 RPM, this went crazy. That got tall. This disappeared. The firing order on this one was 137266548, because an engine like this, even if it's a 5-liter, runs better and has more power as far as performance with this firing order than it had with the 015426378 firing order. And I don't know how they figured that out, but they did. The spikes for 3 and 7 would distort while the misfiring was underway, but as the speed increased, it became even more interesting. This was a screwed up pattern that was only there when I was above 3,000 RPM. Alright, so we started losing cylinders 3 and 2 at 3,000 RPM, and at the same time those cylinders were gone, number 7 would have a big spike. So what in the world did that mean? And I saw a problem like this several years ago, not several years, well, it was several years ago now, but it was even several years before I wrote this article, on a Tempo, a 93 Tempo that had come to my service bay through the body shop after having rear-ended another car. When it ran into the other car, it broke the distributor off. The body shop got a distributor from the old Fred Jones distributor from the parts room, popped it in there, and whenever they would get up to a certain RPM, it would start dropping in the cylinder. It would start skipping, but it idled just fine. And so they shuffled it around to me, and I got to looking at it. And so the pattern at idle, when I put the scope on it, was perfectly normal. There was nothing wrong with it. But as soon as I gave it a little gas, it would drop that cylinder like it wasn't even there. All right, and so here's what I found. Took a few minutes to figure this one out. The Mustang, the way the Mustang was doing it reminded me of this tempo. That's one of the things when you draw on your previous stuff. Some people use their memory for just about everything. Our memory is something we need, but you also need good troubleshooting skills. I trained one guy that was really good at remembering the vehicles he had fixed previously, but if he ran into a vehicle that wasn't like any he'd ever seen before where the problem was given, he would beat his head against the wall trying to figure it out. He wasn't a terrific troubleshooter, but he had a really good memory. Now, a really good mechanic will have both a good memory and also have a good troubleshooting skills. And it doesn't hurt, you know, to look at some of these online databases like IATN and Identifix sometimes to just see what the most common failure on a car is. If it's a platform you're not familiar with, or sometimes if it is, you can save a lot of time. It's kind of like having 1,000 mechanics in the room raise your hand and say, hey, you guys raise your hand if you've ever seen such and such a problem. And if 10 of them raise their hand and say, yeah, I've replaced part X for this, but you know, 2 of them says I've replaced, you got a pretty good idea what the most common place you need to look is. Now, you're not going to get a silver bullet every time from these websites, but you will get a lot of help from people that have already been where you're at and have done some of this trailblazing for you. Anyway, the profile ignition pickup, that's this signal here that comes out of the distributor. It's generated right here, comes out of the distributor, and the engine controller uses that profile ignition pickup to determine what to do with the fuel injection. It's got the narrower vein on one of those things, so it'll know where solder number 1 is. It's almost like a cam sensor. But here's the thing. You know, 91 to 92 to 94. Now this is one that's got more veins, but mine had only 4 veins. But see the narrower segment and the segment that's the same width all the way around? This is what I needed, and this is what I had. When they put that distributor in there, they had got a distributor from the remanufacturer, from Fred Jones or whoever you want to call it, Ford authorized remanufacturer, that had a, it used to be kind of funny. I was at a school one time and one of these mechanics, the instructor wanted mechanics to fill out the paperwork, and he gave one of them a pen that didn't have a pen. And the guy was trying to fill out his paperwork, and he told the instructor, he says, you're going to have to give me another pen. This is a Fred Jones pen, and it won't write. I'm not saying anything bad about Fred Jones, but I mean, I ran into a stump with some of them things too. Anyway, this one here was on that tempo. And so what had happened was tempos went sequential electronic in 1992. They got a cam position sensor to time the fuel injection cycle, and so they did away with that narrower vein. And these body shop guys had put one in there that had a skinny vein, and it didn't belong there. That was the thing. Now, on this particular distributor, the coolest thing about it was, you know, a lot of the times that little vein cup was riveted onto that shaft so that you had to take the distributor apart, which was another job in itself. Of course, I did that 377,214 times, replacing stators and stuff in them distributors. But this one here just had 2 screws, where you could take the 2 screws out, lift the vein cup off, put the other one on from the distributor that was broke, because they still had that. And I put that in there, and I fixed that engine skip because so I said this has got a pretty good chance of being this kind of situation. But it produced a disappearing spark on cylinder number 3, kind of like what we were seeing. It wasn't exactly, even though I put that word in there. The set of circumstances didn't apply to the Mustang since its calibration still called for a signature pip. That's what they were still using back then on those. Now, IDM is Ignition Diagnostic Monitor. Incidentally, let me say this. They went sequential electronic fuel injection on the 86 Crown Victorias. Now, the pickup trucks at that time still have bank-fired injection, but the Crown Victorias used the signature PIP with sequential fuel injection. So you could use signature PIP for that. I don't know why Tempo decided they wanted a cam sensor when they could have used the signature PIP. Some of the stuff they do is a mystery. But anyway, if you look at the scope of all these, Ignition Diagnostic Monitor is basically Have you ever noticed how when you hook your test light up to the negative side of a coil, it's got this pulse? Well, that pulse is what the engine controller is looking for through that IDM resistor. And if I'm not mistaken, that IDM resistor was 18,000 ohms or something. But that voltage spike was something the engine controller could measure. And if it saw it happening, it would know that the coil was firing. And that's what the ignition diagnostic monitor was. Spouted spark output and the profile ignition pickup is this one here. And so this right here and that right there look very similar. You see, and of course there's your dwell, which is technically how long the points are closed, you know, with all using transistors instead of points. Secondary scope pattern on the Mustang remained normal at idle, but was snaggletooth at higher RPMs. Now, this was one I took a picture of on another vehicle I was working on that had the cop coils. And on these Ford pickups that's got cop coil issues, if I've got a bad cop coil on a Ford pickup that's misfiring, you know, which my cylinder contribution, you know, my power balance test showed this, and I go to that particular cylinder, I'm going to pull the plug out and I'm going to measure this. Now, I've talked about that before. Ford Advanced Engine Performance said to do this. They basically had this in one of their little training programs. You're supposed to use an ohm meter, measure the center electrode to see what it was. You're looking for no more than 8,000 ohms, is what they were saying on that training thing. But I was checking the spark plug center electrode resistances a long time before I saw that at the Ford Training Center. The funny thing about it was, and I've mentioned this before, I had written about that in a Motor Age article, and some champion spark plug engineer wrote me a scathing letter saying that nobody but an idiot measures the center electrode on a spark plug because you don't need that. You use a scope to troubleshoot secondary ignition. You don't measure anything with a meter like that. And, you know, of course, proof's in the pudding. This particular spark plug only showed 200 ohms, which was not, I mean, you're supposed to have, usually you'll see from 3 to 6 or 7,000 on a healthy set of spark plugs. However, with all due respect to Champion, and I use those when I'm working on a Chrysler or, you know, something that came with them in it, I took a brand new set of Champion spark plugs just for grins and measured the center electrode on those, and I was measuring from 2 to 17,000 ohms and everywhere in between on that set of 8 spark plugs. So just, you know, let your conscience be your guide on that. Anyway, most of them, though, will measure too much resistance. They'll just be wide open. This was an unusual one because it was almost shorted. All right, in this case, the plugs on the Mustang measured about 3,500 ohms per plug. I didn't have any smoking gun there. Now, incidentally, that is not necessarily a go-no-go test. If they all measure 3,500 or within that range you're looking for and they're all close to one another, you can still have a bad spark plug that's cracked internally and jumping or something like that. So there's some tests that you can trust. You can trust it to tell you the truth if it fails, but just because it passed. One example of that, one that can pass the test and still have a problem, is an alternator. If you measure the alternator, the diodes, by going from the output terminal on an alternator to the case and then swapping your meter around using diode check, it can pass that test and still have other problems. If it fails that test, then that, you know, you're done. If it passes the test, you still got some more checking you got to do because it can pass that test and still have other issues. That's the same way with spark plugs. When the plug's reinstalled and the spark plug wire out and rechecked for parallel induction crossfire problems, incidentally, on the 302 and the Chevys, you know, and the Dodges, there is if two of the plugs in the firing order are right next to each other on the distributor cap, and if the same two plugs that are right next to each other on the distributor cap are next to each other down there on the engine, and you're trying to be a really good mechanic and make it look really neat, and you run those plugs right next to each other in that loom all the way down there to the spark plug, you can have some induction fire, crossfire induction, because it'll fire the one that is not supposed to be firing yet, in other words, while the sparks are running through this wire here, it'll actually get over in the wire next to it. The spark won't jump over, it just induces a spark in that wire. And it can fire that spark plug early and cause a labor knock on one cylinder and burn up plugs and stuff like that. So what you're supposed to do is take in your little loom there, you separate this wire right here all the way to that side, so that there are other wires in between them, because you're not going to have induction crossfire unless the two plugs on the cap that are next to each other are running all the way down to the two plugs on the engine that are right next to each other. Now that happens on the Ford firing orders on some of these V8s and on the Chevy, because if you think about it, 1843657 you know, 5 and 7 are right next to each other on the Chevy, and on the Ford it's 1542637 7 and 8 are right next to each other on the Ford. So you just got to make sure that you don't have induction crossfire. If you ever experience that, you won't forget it. All right. Number 3, though, the tower was going dark and dead at 3,000 RPM. All right, and so this is not a good photo of what we got on that scope. But when we checked it, we scoped the profile ignition pickup, we actually would suddenly get this whenever we brought it up to 3,000 RPM. That was measured on the distributor connector pin 4. You know, and that was this one right here. See, and that's the profile ignition pickup. All right, instead of a nice square wave, we noticed one wave was becoming twice as wide as all the others. At the exact moment it started skipping. So this is going to be where we need to look. You know, and there's your little, you know, cup and your stator in there and all that. What I saw turned out to be some nasty signature marks on the inside of the stator where the Hall effect magnet had been hitting the vanes. All right, we tracked it down to that. The bad one, when seen from the top, looked like this. Look what a screwed up mess that is. This was a cheap part. And this right here is what the new one looked like that came from Motorcraft. And there's a, you know, zoomed out view of that, where this magnet right here had been hitting that. Now, why it did it at a higher, at over 3,000 RPM, I don't know. But whenever we replaced this stator and stopped that contact, this wasn't damaged to the point that it couldn't be used anymore. We put that back together and it was in good shape. That's the end of the slideshow. And I hope you got something out of this. And I appreciate you guys watching me. And let me give me some comments or encouragement or discouragement or whatever. And I will talk to you guys next time.